My name is Ed Zynda, and I am the blockchain developer and one of the co-founders of Wild Crypto. So in just a short amount of time, next month, starting September 5th, Wild Crypto is planning to launch its ICO, or initial coin offering, which will allow your average investor to go ahead and purchase Wild Crypto tokens for use on the Wild Crypto e-gaming platform. So in the interest of transparency, I am going to detail in this video the actual source code that will be deployed on the Ethereum blockchain for the Wild Crypto ICO CrowdSale. So let's just dive right in. So here you see the actual source code, and I'm just going to kind of scroll down and detail and describe everything line by line. So the first portion is basically telling Ethereum which version of the Solidity compiler you want to use, and that's the latest right now, so 4.15. And then the next piece right here is a library called SafeMath, which helps us avoid any sort of bugs or funky things that might be happening with any mathematical calculations we're doing in our contract. So the library itself is actually copied and pasted from a really nice project called Open Zeppelin, which is just a GitHub repository full of peer-reviewed smart contracts that are open source and freely available for anybody to use. And I've only copied two methods from this library because we're only going to use these two. And I do this only to keep our contracts smaller and lighter. And in the programming world, the less code you use, the better, and the less chance you have for bugs. So as you can see right here, I've got the multiplication and the addition functions that we will use later on. This next piece right here is actually a full contract definition called Ownable. This is also copied from the Open Zeppelin Solidity library of contracts, and this is a really neat library or a contract which allows you to set any contract you create, if you inherit from this contract, to have a kind of authorization or user permission control. So if you write any contract and you inherit from this ownable contract, you automatically get this owner variable. And then when you create that new contract, the Ethereum wallet that creates that contract becomes the owner of the contract. And then you can use this modifier called onlyOwner on specific functions in your contract that only the owner of that wallet can actually call. So this is a nice layer of security for different administrative functions that you might have on your contract. So we have this onlyOwner modifier, and a modifier is basically just a keyword that you add onto a function which adds some added behavior. So we've got this onlyOwner modifier, and then we have a transfer ownership function. So just in case you don't want the creating wallet to stay the owner of whatever contract you create, you can go ahead and transfer that to a different wallet if need be. This next section right here is called an interface, which allows you to basically create a type in Solidity. So Solidity comes with base types. So you have integer, Boolean, which is true or false, strings, and then a few other different types. But you can create other types and then give them, describe some behavior for them, and then you can actually create more variables using this type. So we've created this type token, and this token type is basically to represent the wild token contract that is already deployed on the mainnet Ethereum blockchain. So here is the actual source code for the wild token contract that's deployed. And as you can see, there are quite a few different functions involved in that contract, but in this case, we only care about 2 of those functions. So we can abstract that, reference this transfer function and this balance of function, and then use those in our type. And this will allow us to latch on to the actual deployed token and then call those functions from within our new contract. This next portion is the actual meat and potatoes. This is the CrowdSale contract. So we call it CrowdSale, and to extend from that ownable contract that we talked about earlier, we just say is ownable, and that will give us all the functionality of that ownable contract, and then we can use it. And then this line right here, using safe math for uint 256, this will attach that safe math library to the uint 256 type. So if you have a uint 256 variable, you now have these added multiplication and addition methods that we created up at the top of this file, and you can actually call those against that those variables, and I'll show you that down below. And then the next portion, we start initializing the variables that we're going to be using in our contract. So we have this token variable. Like I described before, it's of type token, which is described right here. The next, we have the rate. So if we look at the Wild Crypto ICO description, we're planning to raise 15,000 Ether and then award 2,000 wild crypto tokens for every Ether contributed to the ICO contract. So over here, the rate, number of tokens per Ether, we set it to 2,000. And then we set the cap, or the goal, to 15,000 Ether. This next variable right here is the start time. And start times in Solidity need to be in what are called Unix timestamps. So the actual start time of the CrowdSale is September 5th, 2017 at 8 a.m. London time, which is GMT +1. You can also use UTC in place of GMT, depending on who you're talking to. And the way I got this timestamp, you can just go to Google and just Google date to Unix timestamp converter. I found one right here, and basically all I did was enter the date and time I wanted to use. And because London is actually 1 hour ahead of GMT or UTC, I went ahead and entered the time 1 hour earlier to match with what would be in London, and this is the timestamp that it gave me. So that's what I copied and pasted here. And the CrowdSale is supposed to last for 7 days. So this variable is the amount of days the contract is supposed to last. And I just made a mistake here. These all should be constant, meaning that they're not going to change. And this basically allows for when you deploy this contract, when the compiler sees this constant keyword, it will actually create some useful utility functions that you can call on the contract to actually return the value of these variables. So it knows that the state of the contract or the blockchain is not going to change when you call these functions. So you get these functions for free. So you get a rate function, a cap function, start function, days function. So we're going to use all these in our calculations later on. The next variable is an initialized variable. And I added this for just an added check to make sure we have all of our ducks in a row when we start the crowd sale. And I'll describe what I consider initialized later on. And then we have this public raised amount, and this will be viewable by anybody viewing the contract. So we set it to 0, and we just want to keep track of how much we've actually raised during the course of the crowd sale. This right here is an event, and an event in Solidity is basically just a way to log information on the blockchain. So it's not a function, it doesn't really do anything, but it does actually save data to the blockchain. So basically all we want to log is who bought the tokens. So this address is from whoever is purchasing the token, and then how many tokens they bought. And then down here we've created a new modifier called when sale is active. So we will add this to the function that is used to buy and distribute the tokens, and we only want to be people to be able to buy tokens when the sale is active. So this actually makes an assertion. I've created another isActive function. I'll describe that below. So it makes an assertion that this isActive function returns true, and then if it does, it'll continue. If not, it will exit out, and then you won't be able to buy tokens. And then this right here is basically just a placeholder. So you add this modifier to a function, and if everything passes, just imagine that the rest of the function that you're modifying is run at this point right here. This next function is called the constructor. So you give it the same name as the contract that you're creating, and this is just a way to do some basic setup for your contract when you deploy it. And what we're doing here is passing in the address of the deployed wild token contract. So when we deploy this, we're just going to pass that Ethereum address into it. I'm just going to make sure that it's an actual address just for safety. And then we're going to initialize that token variable that we set up above with the new address. So now this token variable will reference that deployed wild token contract. So down here I've created this initialize function, and this initialize function basically will make sure that there is the correct amount of tokens that sent to this contract address. So the first thing we need to do is deploy this contract, and then the second thing we need to do is take 30 million tokens from the token contract address, and then allocate those to the CrowdSale contract. So when we initialize, we're going to pass in the number 30,000 plus 18 zeros, which is only because the token that we set up has 18 decimal places, and then everything in Solidity, all the numbers in Solidity work basically in whole numbers. There's no such thing as a floating point number, and so we do floating point math by adding extra zeros and then doing some nifty things that way. So when we represent the number, we're going to pass in 30 million plus 18 zeros. We're going to make sure we haven't tried to initialize this before, and then we're going to check that there are 30 million tokens allocated to this contract, and we do this through this tokens available function down below, and basically that just calls the deployed token contract and the balance of function, and then this is the reference to the address of this contract once it's been deployed. So we require that those two numbers are equal, and then if everything checks out, we set initialize to true. Now, one thing I forgot to add to this is to check whether this is initialized in order to set this CrowdSale to active. And we'll just add this below as I describe this. So we've got this isActive function, and it returns true or false depending on whether or not it meets this criteria. So the first piece, we're going to add this right now. We want to make sure that initialized is equal to true. So that's the first check we're going to do. And then the next check, we want to make sure that now, so the current time, is greater than or equal to the start time. And Unix timestamps are in seconds, from dating back from some date in 1970, I believe. So this is the number of seconds from that date. That's how Unix timestamps are calculated. So any time later than this will also be larger than this. So we want to make sure that the current time is larger than the start time, which we described above. And we also want to make sure that the current time is less than or equal to the start time plus the number of days we set, which was 7. So it has to be after the start time, and it has to be before 7 days are up. And then the last check we want to do is make sure that we haven't already reached our goal. If we've already reached our goal, we don't want to continue this CrowdSale. And this goal reached basically is a function down below, right here, and that returns true or false based on whether or not the raised amount is greater than or equal to the cap in Ether, so 15,000. And then we multiply that by 1 Ether. And Solidity is actually pretty cool, and that actually lets you use the Ether keyword to represent Ether, because all Ether values in Solidity are these really big numbers, and they also have 18 zeros to represent the number of decimal places. So all Ether values in Solidity contracts are represented in Wei, which is the smallest denomination of Ether. So think of it like cents to the dollar, or cents to the dollar is probably the best way to think about it. But Wei to Ether is like a really huge number. So the easiest way to work with that is just to multiply it by one, and then the Ether keyword, which is right here. This next function is a function without a name. And a function without a name is called a fallback function. And these are kind of useful in Solidity, and that allows you to send Ether amounts straight to the contract address without calling a function. So it's easy for your average user to just send Ether to this contract address and then get their tokens back. And they don't have to worry about learning how to use the Mist wallet or something to actually interact with Ethereum contracts. So in order to do that, we create this function without a name. We give it the payable keyword, which says that, hey, this function accepts Ether. If you don't use this payable keyword, the transaction is going to fail. And because we want to do all the work in a separate function, we call this buytokens function. So in order to purchase tokens with this CrowdSale, you can actually call this buytokens function directly, but instead I would recommend just sending Ether to the address. But if you wanted to, you can actually just call this buytokens function directly. So this buytokens function is how we calculate the number of tokens to send to an address. We set it to payable because it needs to be payable as well. And then we add this when sale is active modifier. So this function will only work when the sale is active, when we already went through the checks earlier. So if it's not active, then the CrowdSale is essentially done, and you're not going to be able to buy any more tokens. So we calculate the tokens to sale. So I've got this Wei amount variable, which basically reminds me that the amount that's going to come through is going to be represented in way, which is like a huge value. So for example, if somebody sent 5 Ether, it's basically going to be 5 with 18 zeros. And we get the value sent to the contract using this global message.value variable. So this is in reference to the actual value set to the contract when someone buys. And then we've got this tokens variable. And what we're going to do is multiply the way amount using this safe math multiplication method by the rate. So we're going to multiply however amount of Ether by 2,000, and that's how we're going to get the number of tokens to distribute to the buyer. And what's great is that the wild token is actually set up to mirror Ether in that it also has 18 decimal places, so this math works out really simply. Then we call this bought tokens event, and basically that just logs on the blockchain that, hey, somebody bought tokens, and this is how many tokens they bought. And then we're going to increment the raised amount. So we will add the amount of Ether raised, or add the amount of Ether sent to this function to the actual amount of Ether raised in total during the CrowdSale. And that's how we keep track of that. And then the next step is actually sending the tokens immediately to the buyer. So we call the deployed wild token contract, we call the transfer function, and then we send it to the buyer, which is referenced by this global variable message.sender, and then the number of tokens that we calculated above. And then the transfer function knows to send it from this particular contract's address, because we've allocated tokens to this address, and then it knows to send those tokens from this ICO contract address. And then the last step is to send the Ether to the owner of this contract, which will be the Wild Crypto team. And if any of these two fail, it will actually roll back the transaction, and then none of this will actually be persistent. So I don't really need to do any checks on whether or not tokens exist. That's already taken care of in the token contract, and then the Ethereum transfer, that's taken care of by Ethereum itself. And then the last two pieces we have in this contract are this tokens available function, which is basically just a convenience function. It allows anyone viewing the contract to kind of get a glance of like how many tokens are actually available. And basically it's just a proxy for this token.balance of function in reference to the deployed wild token contract. And then this last function is a cleanup function. So if for any reason the token sale ends and we have any tokens left over, we can clean up by running this destroy function. So it's going to take the remaining tokens, send them back to the owner of this contract, and then actually destroy the contract. So cleans up the blockchain and nobody can use this contract again. So that's the gist of this CrowdSale contract. The contract code itself will actually be posted on GitHub later, and it will also be published on etherscan.io. So when we publish our contracts to Etherscan, we verify it by comparing the deployed contract code with the contract code we submit. So that's how you know that the contract is legit and we're not trying to pull any funny business. So when everything's set up, feel free to have a glance, and you'll be able to view any changes or tweaks that we might have made since this video was made. So feel free to check that out before you invest. And I hope you enjoyed this video, and I look forward to seeing you at the CrowdSale.